Hi, welcome back to the Module 6 of Design of Mesh Elements. Our today's learning objectives are: define the terms stress concentration and stress concentration factor, realize the importance of stress concentration in design of mesh elements, elucidate the design guidelines, discuss the methods of reduction of stress concentration. First, let us see what is stress concentration. Localization of high stresses due to the irregularities present in the component and abrupt changes of the cross section is called stress concentration. You can see here, because of this hole, stress is locally increased here. This is called stress concentration. Stress concentration factor is defined as it's a ratio between highest value of actual stress near discontinuity divided by nominal stress obtained. Causes of stress concentration: variation in properties of materials, load application, abrupt changes in section, discontinuities in the component, machining scratches. All these causes stress concentration. We will see it one by one. Variation of properties of materials. Here, some internal cracks, flaws and cavities, air holes for inclusions, all those things can change the material property. Due to this change in material property, there may be localized stress that may cause stress concentration. And whenever we are applying a load at point or at a line, there will be a stress concentration near to that load applied point. And in most of the cases, our component will not have the same cross section throughout its length. There may be changes in cross section. These changes in cross section causes stress concentration. Then there will be discontinuities in our component, like keyholes as shown in figure and some slots. All those things causes localized increase in stress and stress concentration. How to find stress concentration factor? Through some graphs. We will deal it in detail in the next module. Design guidelines. For ductile materials under static load, we need not consider stress concentration, because even though if there is some changes in cross section or small cracks, there will be yielding near to that point. That yielding gives the that yielding reduces the stress concentration, so we need not worry about for static loading in ductile materials. But if the same ductile material is subjected to dynamic load, we need to consider stress concentration. And for brittle materials, regardless of loading condition, we need to consider stress concentration. Okay, how to reduce stress concentration? We will see it here. By providing additional notches and holes in the tension member. See this line, if this line changing too much, there will be high amount of stress concentration. To reduce that, we can provide notches or holes like that, so that this abrupt changes is reduced. You can see from these lines. Here change is too much, here there is no much change. And by providing fillet radius, undercutting and notch for member in bending, all these things also reduces stress concentration. You can see here, for a bending case, if this cross section is it is abrupt, this line changes too much. To reduce that, you can provide fillet radius so that the line change is reduced, and you can provide undercut or notch. All those things causes reduction in stress concentration. And in case of shafts, you can provide additional holes that will reduce the stress concentration. In case of threaded fasteners, you can provide some undercut or you can make the shank diameter equal to the minor diameter. By doing so, you can reduce the stress concentration. And in our next live class, we will see how to design for cyclic loading. Thank you.